Before we begin our Chapter 8 lessons, we need to understand the concept of balancing our equations. So I have a scale here. It's perfectly balanced. It has the same number of pieces on both sides of the scale. Same number of yellow pieces, red pieces, blue and green pieces. And therefore, the scale is balanced. If, however, I go over here and I pull a couple of pieces out, now the scale is out of balance. You can see that. All right, and we can't have that, not in math. So we're going to make sure our scale is in balance, that we have the same number of pieces on both sides. All right, we're good. It's back to balanced again. All right, so let's take a look at what that means in terms of math. So if we have an equation, let's say we have 3 plus 2 equals 5. If we take out that 2, 3 does not equal 5. That doesn't work, does it? So if we take out a 2 on one side, we have to take out a 2 on the other side. Now we have 3 equals 3, right? Because 5 minus 2 is 3. And these two canceled each other out. They made a 0. 3 does equal 3. All right, let's take a look at this with our model. Okay, so let's say, I'm going to make up a number. We have 12 pieces. Well, let's count them. We have 1, 2, 3 yellows. We have 4 blues, so that's 7. We have 6 triangles, so what is that? 13 and 2 reds, so that's 15 pieces on each side. Both sides have the same number of pieces. All right, so we have 15. And so we have 15 equals 15, right? So let's write that down. 15 equals 15. That's what we have right now. If I take 2 yellows out, 1, 2 out of this side, so I subtract 2, that's 13 equals 15? Let's take a look. No, it does not equal, does it? They do not equal. So if I'm going to take some away from one side, I have to take it away from the other side also. 1, 2, and it's going back to balanced again. All right. So what if I take out, let's say we take out 3 green pieces. Or we just do it from one side first. Let's go take 3 of our little triangles out. We have 1, 2, 3. And, well, let's take out more. Let's take out 5 of them. All right, let's take a look. All right, we are back out of balance. Okay, so we took away 5. So now there's only 8 pieces on this side. Well, there's still 13 on this side. So it's not going to equal. So we have to do the same thing over here. Let's go 1, 2, 3, 4, 5. Okay, it's got to be the same as that side. Good, now we're the same. And we're going back to balance again. as it works its way back. Okay, so because we took 5 off of this side, we now have 8 equals, all right, so we had 8 equals 8. So we have 8 pieces on this side left over, 8 on this side. So let's write that as a formula over here, but let's break one side out. We'll do 4 plus 4 equals 8. Okay, so 4 plus 4 does equal 8. So let's take 4 out of this side. We'll take the 4 blues out. 1, 2, 3, 4. And that throws our scale out of balance. The right side's heavier now. So we took 4 out of one side. So what do we need to do to this side to keep it in balance? Because we just made a 0 here, right? A positive 4 and a negative 4. We made a 0. Those two canceled out. So we only have a 4 now on this side. Equals, so what do we need to do to this side in order to keep it balanced? Well, we need to take those other 4 pieces out of this side to keep it balanced. 1, 2, 3, and 4. And we're back in balance again because we removed the same number of pieces from both sides. Same thing with our equation. We remove 4 from both sides of our equation and we are back in balance again. So anything we do to one side, we have to do to the other. In our regular scale here and in our equations, anything we do to one side, we have to do to the other.